A factor means numbers that divide into a number. So if you have the number 8, you're going to think of the numbers that go into 8 if you're dividing. So could you divide 8 by 1? Yes. How about 2?
Yeah.
How about 3?
No.
No. How about 4?
Yes.
How about 5?
No.
What about 6?
No.
Nope. What about 7?
Nope.
And what about 8?
Nope.
Yeah. 8 divided by 8 is 1. So we have 1, 2, 4, and 8. Now, you don't have to write all of these out. I was just doing it to show you that we're going to look at all the numbers to find out if they go into 8. So all you have to do if they say what are the factors of 8 is you write the number 8 and you write equals 1, 2, 4, and 8, and you separate them by commas. So that is one way, that's the most common way to show a factor. If we have a bigger number like 64, you're obviously going to have to do a little bit more work. So we can go into bigger numbers after. Right now we're just going to go into like a kind of a medium number. So we're going to try like the number 20. Does 1 go into it? Yes. Does 2 go into it? Yes. How about 3? No. 4? Yes. 5? Yes. 6? No. 7? No. 8? No. 9? No. 10? No. As soon as you get to the halfway point, you get to close off with the number that you started with. Because there's not going to be another number once you get to the halfway point that will divide evenly into it. Now, here's the thing. We might forget one of the factors. So I'm going to show you this thing. Most schools call it a rainbow. You could match up all of these factors together and they will make a multiplication fact. So 1 times 20, 2 times 10, and 4 times 5. Same with this. 1 times 8 and 2 times 4. If you have...
Except it's kind of like in like a T.
Okay, perfect.
You draw a T, then on one side you put like what it's divided by, then you put like what it's divided by.
Okay, perfect. Something like this, like 16, we would say, does 1 go into it? Does 2 go into it? 3, 4, 5, 6, 7, 8. Now we're at the halfway point, so we close it off. Now this one does not have a match. The only ones that are not going to have a match, I just do this, because 4 times 4 is 16, right? So if it's a multiple like 5 times 5 or 6 times 6, the match is going to be itself. So I just still do a rainbow and match it up. I just match it up with itself like that. Does that make sense? Okay. Now, there's something called a prime factorization tree. Now, this is something you might learn coming up. You'll definitely learn it this year. I'm assuming you're going to learn it now. So, let's go over what a prime number is. I don't know if you've talked about prime numbers and composite numbers, but...
I don't think we talked about the lower one, but we talked about prime.
Okay, so prime number only has 1 in itself, like 1 in 2, 1 in 3, 1 in 5. There's no factors other than those ones that go into it. Now, if it's not a prime number, it's a composite, which means it has more than 2 factors. Prime means only 2 factors. So an example of a composite number is the number 4. 1 goes into it, 2 goes into it, 4 goes into it. Another composite number is 1, 2, 3, 6. Does this have more than 2? Yes, so 6 is a composite number. How about 8? 1, 2, 4, 8. Yep. Now, some kids look at this pattern and they say, oh, you mean even and odd. No, I do not mean even and odd. Because look at this. 9 is an odd number and it is a composite number because 3 times 3. So it has nothing to do with even or odd at all. You actually have to go and look at all the numbers, like 21. 1, 3, 7, 21, right? Composite, even though it's odd. So it has nothing to do with it being even or odd. Now, a prime factorization tree is an easy way to kind of get all of the factors down to prime numbers. So if you have the number 21, what are two numbers that go into 21? And you would never use the 1 in 21 because you would just keep going 1 in 21, right? We want to get this 21 lower. So we never use 1 in them. So what is another factor set that I could use for 21? Yeah, so I write a 3 here and I write a 7 here. And once my number here is prime, I circle it. And then I list them out. 3 times 7, and this is how we write it. 3 times 7 or 3 times 7. Let's try a trickier one. So the number 16. What are two factors that go into 16? Any two factors. Something times something equals 16.
8 times 8?
No, 8 times 2. 8 times 8 is 64.
No. Yeah, 8 times 2.
Yeah. So 2 is a prime number, so I'm going to circle it, but 8 is a composite number, so I'm going to continue my factor tree until I get all prime numbers. So I have 8. Now what are two factors that go into 8?
4 and 4?
Okay. 4 and 2. So you're saying 4 times something. 4 times 4 is 16, but 4 times 2. You're always going like dividing. 8 divided by 4 is 2, or 8 divided by 2 is 4. Does that make sense? So this is a prime number, so we can circle it, but 4 is still a composite number. So what two factors can I use for 4?
2 times 2?
Yep. And now we have all prime numbers, so we list them out. 2 times 2 times 2 times 2. Now, whenever it is like 4 of these, you write 2 to the 4th power. If it was 2 times 2 times 2, you would write 2 to the 3rd power. So, have you learned about exponents yet like this?
I don't think so.
Okay, so I'll teach you about that as well. So, an exponent has two parts to it. It has a base and it has the exponent. So the base is like the 2. So 2 times 2 times 2 times 2. The base would be what you're multiplying, and the exponent would be the number of times that you're multiplying the number out. So this would be 2, and it's called to the power. So 2 to the 4th power. If you had 6 times 6 times 6, the base is 6 and the exponent is to the 3rd power. Now, they do something kind of crazy. When your exponent is a 2, they call it squared, so 2 squared. And when it's a 3, they call it cube or cubed. So you would say 6 cubed, and suppose you had something like that, it would be 2 squared. So what this means, if you had a 4 squared like that, this does not mean 4 times 2, it means 4 times 4. So you could see that these numbers go up pretty quickly. If I had 4 to the 4th power, it's 4 times 4 times 4 times 4. So, George, what is 4 times 4?
8.
4 times 4.
4 times 4. 16.
Now we take that and we do another 4. So we do 16 times 4 is 64. And then we do another 4. 64 times 4 is 256. Okay, so those are the two things that will help you with prime factorization, is doing the factor tree like this, knowing whether it's prime or composite, and then being able to write the answer in an exponent, base and exponent. All right, any questions about that?
I don't think so.
Okay.